Hi, my name is Steve Moran. I'm the manager of ocean test facilities for the Northwest National Marine Renewable Energy Center. My job as ocean test facilities manager is the overall development of the model that we'll use to test technologies in the open ocean.
My name is Katie Hildenbrand. I work for Oregon Sea Grant Extension, which is a part of Oregon State University. I do a lot of work with the Northwest National Marine Renewable Energy Center on connecting and working with ocean stakeholders.
My name is Sarah Hinkle. I work at the Hatfield Marine Science Center, and I'm a researcher with the Northwest National Marine Renewable Energy Center. I'm one of the lead researchers looking at potential environmental effects of marine renewable energy installations, and my primary focus are the habitats and organisms that live on the seafloor on the bottom of the ocean.
My name is Joe Haxel. I'm a research assistant with a Cooperative Institute for Marine Resources Studies at Oregon State University. My work with NNMREC focuses on acoustic monitoring of wave energy conversion devices off the coast of Newport at the Ocean Test Facility.
NNMREC was formed on the idea that the technology is only one piece of the overall picture for the industry. We're concerned about the bigger picture and what the potential impacts for this industry could be.
So Human Dimensions work is really social science research. Social science research includes cultural aspects, it includes societal aspects and political aspects. There's been several different projects focusing around these topics, including looking at marine spatial planning and sort of the different ocean users that are involved in ocean decision making. Outreach and engagement uses a lot of that data as we make an informed audience to help us make decisions about our own testing and research areas, but also as we inform other partners that we work with in other companies on how they should also approach communities and make plans for their testing.
Wave energy is in its infancy right now. We don't really know what types of devices are going to be the best and where they're going to be best utilized and what the impacts could potentially be of those technologies. We're here to answer those questions. We care about the impacts to benthic habitat and the ocean ecology and to the socioeconomic environment around this industry.
So some of the potential impacts to a benthic community, benthic just meaning bottom, are changes to the type of seafloor or habitat that they have available to them. So the installation of large concrete anchors is going to change some of the seafloor from sand or mud to a hard bottom, and new kinds of animals might colonize those hard anchors. We'll also see some changing of the kinds of sand or mud that's on the bottom, in the same way that when you put a rock in a stream and you get scour around that rock, you might see scour around these large anchors that are installed on the seafloor.
The reason acoustic is important is because marine mammals in particular, and fish use sound as a means of navigation, communication, choosing habitat, and stalking prey. The focus of our research is looking at impacts from sounds generated from the mechanical parts of the wave energy conversion devices and what that contribution of acoustic energy is to ambient levels.
What we're primarily engaged in now is what we call baseline research, and that's really important to look at the condition of the habitat and the distribution of the animals before we put these installations in, so we can understand how they might change after the installations are in the water. So what we do right now is we take samples of the seafloor and make collections of organisms and try to determine how they vary over space and over time in a natural setting.
The components of sound that we're interested in, ways to describe the energy associated with acoustic signals, are number one, the amplitude of the sound. Essentially, that's how loud the sound is. Number two, the duration of the sound, how long that sound acts on that environment. And number three, the frequency that that sound's occurring, so what the pitch is essentially. These are all components that are important for analyzing and assessing the impact of particular sound transmissions from mechanical devices and development in the coastal zone.
The ocean's a challenging environment. These devices have to survive for long periods of time. They have to survive large storms. They have to prevent biofouling. They have to generate energy in a reliable way with requiring minimal service. And so it's a challenging environment, and it's a big challenge for the industry. We hope to solve those questions.
Now that we have a location selected for the Pacific Marine Energy Center and we move forward, really our work with that community just begins. Even though they were really heavily involved in helping us select a site, really the work with them is just beginning. It's really them that are going to help us sort of get through the regulatory and permitting process. And it's really building a relationship with them and having a connection with them that's going to allow us to get the infrastructure that we need and continue to have good partners in that community as we move forward.
I'm excited about this industry because not only do we get a chance to help write the story of our clean energy future, we also get to experience the natural environment. We get to see a variety of devices come out of the ocean and see how they perform, how much energy they make. We get to solve these problems and have fun while we're doing it.